Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, in this video, we are going to create a RAG, that is an LLM app, which is nothing but Retrieval Augmented Generation, where we'll try to query from multiple PDFs with the help of Llamaindex and Openai. Now this was one of the project where people were requesting like anything from past couple of weeks. So that is the reason I thought of why not create this specific project for all of you. Now, since we have already started the playlist of Llamaindex, step by step, we will go ahead and build some amazing RAG system, more complex, advanced RAG system. We'll try to use vector databases, we'll try to use external database, and we'll try to see how we can easily retrieve in the form of queries, right? So let's go ahead and let's build this specific project. We will completely start from scratch. Please make sure that you hit like for this specific video, and we'll keep the like target to 1000 as usual I say in every video. So please try to do that and share with all the friends as you can, and make sure that you implement multiple things and do tag me in LinkedIn because I really want to check your implementation too. So let's start from basics. We will go ahead and start. So first of all, I will go ahead and open my terminal, and here we are specifically going to use Llamaindex along with Openai, right? API. So I'm going to create a command prompt. So quickly, let's do conda deactivate. First of all, we will start with creating the basics from creating an environment. So for this, I will go ahead and create conda create. Now see guys, creating environment is through 3 different ways. I've already created a video in my channel. So conda create -p, and here we are going to use venv python double equal to 3.10 with y. Okay, so here what is basically happening, we are going to create this venv environment, and then we are going to activate this specific environment. Now as soon as I probably go over here, so here you can probably see venv environment. Now what is the main task in this specific project? Okay, here there is a data folder. Here you can see that I have 2 PDFs. One is attention is all you know it, and one is YOLO.pdf, right? We will try to read this particular PDF, convert this into a vectors or in the form of index, and then we'll try to retrieve any question if I ask, any query if I ask with the help of Llamaindex, I should be able to retrieve all the details from here. So this is in short a Retrieval Augmented Generation LLM app, right? So yes, the environment has got installed. Now I will quickly minimize this. I will go ahead and write conda activate venv, and remember this process I'm going to probably do for each and every project. Okay, now this is done. I've already covered this usually. Now over here, I've created this .env folder. The reason I've created this because I'm going to use my Open API key, right? So that is the reason I've created .env. I'll not show you the key, but you just need to write OpenAI API key _ API key, and that will be your key name, whatever you are specifically getting from Open API, right? Then along with this, you have this data folder. You can put any PDF as you want. It is up to you. Okay. The third thing, I am going to create a requirement.txt. Now inside this requirement.txt, I am going to install 3 important libraries. One is the Llamaindex. The second one is something called as OpenAPI. And the third one is nothing but PyPDF. So these 3 libraries I'm going to specifically install. So let me go ahead and write pip install -r requirement.txt. Oops. So I'll go clean my screen. So let's go ahead and do it. Pip install -r requirement.txt. So all this installation will specifically happen because I require this 3 libraries altogether. Now, as we go ahead with this specific playlist, more amazing projects I'll come up with, where I'll create more advanced RAG system. I'll include databases. I'll try to use LangChain. And through this way, you will be able to implement things in an amazing way itself, right? So yes, let this installation basically happen. And then I've also created my test.ipynb file. Initially, I will show you in this specific way. You get a crux, you get an idea about it. Then from the upcoming projects, we'll convert this into an end-to-end project with deployment. Okay, so all that is the pattern that I really want to follow. But again, the main thing is that I really want to show you how you can learn these things also. Okay, so let this installation basically happen. And at the end of the day, guys, please make sure that you practice. Unless and until you don't practice, you will not be able to understand. So that is the reason, implement along with me so that you will be able to understand. If you get any errors, if I get any errors, I'll try to solve them. And if you find any issues in this, you can directly ping me. So guys, the installation has taken place. Since I'm using Jupyter Notebook, I'll also install one of the library. I'll clear the screen and I'll write pip install ipykernel, because I will require this to run my Jupyter Notebook. Okay, so pip install ipykernel. One more library that I specifically missed was something called as load_.env. The reason why I use load_.env, because I need to load the environment variable. So for that, I will be using this library is called as python-.env. Okay, so let me do one thing. First of all, I'll install this ipykernel and then probably go ahead and again install all the specific libraries. Then I will be very much like we will implement it step by step. I'll write all the steps over here. Initially, what we will do, then how we are going to use the Llamaindex, how you are going to probably convert all the content inside the PDF. First of all, loading the PDF. Then inside the PDF, what all text are specifically there, how we convert that into vectors. And then with all those vectors, how do we convert and how do we do the indexing using this Llamaindex? All those things we will try to discuss. Now let's quickly go ahead and install the requirement.txt again. I think this is done. Perfect. I will clear the screen. Now we are good to go. I will go ahead and select my kernel 3.1.0. Now let me go ahead and save it. Now everything we have set up in .env file, everything we have. Now it's time we go ahead and implement our solution. Now the first thing over here is that I will go ahead and import OS. Okay. Now, the reason why I'm importing OS, because I'll set up my environment variable, okay, my environment variable with respect to my OpenAPI key. But before that, I will go ahead and write from .env. I'm going to import load_.env. Okay. And then let me go ahead and initialize load_.env with this. So once I probably execute this, that basically means all my environment variable be ready over here and it will be loaded. Okay. So this is the first step. Now in the second step, I will go ahead and write os.environ. And here I will go ahead and write os.getEnv. So I have my os.getEnv, and let me go ahead and call my API keys, right? And with respect to this, my API key will be nothing but it will be something like this, open API key. So now I think you got a complete idea like how we are specifically calling the API key over here. So it will be nothing but os.getEnv, and inside this I will set up my environment variable, and my environment variable will be the same thing over here, right? So this is done. Now with the help of this environment variable, any open API key, I will be able to call it and I will be able to use it. So that is the reason I have written in this specific way. Now, what is our aim? Now understand first thing, guys. Here is my data folder. It may have any number of PDFs. I have to pick up all the specific PDFs. So in Llamaindex, you have a lot of different functionalities which will be able to pick up all this particular PDF or load this PDF and convert this into vectors or indexings. Okay, some indexes. So let me just go ahead and show you how things can be done in that specific way. So first of all, what I will do, I will go ahead and write from Llamaindex. I'm going to import two important libraries. One is vector store index, and then I will also have simple directory reader. Now, since I really want to read it from the directory itself, so I'll be using simple directory reader. Vector store index will be responsible in converting all the text into vectors, and it will index those vectors. Okay. So the next thing what I will do, I will go ahead and write documents is equal to and simple directory reader. Now you know where all my PDFs are present inside my data folder in the current project location inside my data folder. So I will write data dot load underscore data, right? See, there are multiple ways. You can also take PDF, convert that into a text, and then convert into a document also. So once I specifically execute it, here you will be able to see that it will take some time, 2 seconds hardly. So it has read both this PDF. Now, if I really want to verify it, you will be able to see if I write document. So I have all my data. Now in short, this document is basically creating the metadata, all those information. See, attention.pdf, it has all the information, all the content inside this particular document. You will be able to see the content also. So perfect. So this is what is my first step. I have created my documents over here. Now I will take all these documents and convert this into an index. Okay. Now to convert this into an index, what I will write, I will go ahead and write index dot vector store index, which I have already imported, right? I will write dot from documents, and here I'm going to basically use documents. So in short, what I'm doing, I'm taking all these documents that I have and I'm converting this into an index. Okay. There is also one very important parameter. So in short, what is basically going to happen that inside these documents, whatever the PDF content is there, it is going to convert that into vectors and then it is going to index them. After this, you'll be able to see that I can also give one more parameter just to show how quickly, and there is a parameter which is called as show progress is equal to true. Okay. So when I write show progress, it will show me each and every step and how much time this generating embedding is basically taking, right? So hardly 3.9 seconds. And here you'll be able to see that all the indexing is done. So if I probably go ahead and execute index, so this is my vector store index. So in short, it is basically created the vector store index in the form of word embeddings. Okay. I will show you how you can save this index also. Okay. So once this is done, now from this index, I can directly query any question that I have. Okay. So for that, what I will do, I will write query engine. I'll create a query engine. Okay. It's just like a search engine. Okay. And I will say index dot as chat engine also option is there. I will show you as chat engine option, as query engine option. Right now we'll focus on as query, and in the upcoming projects when we create more complex RAG system, at that point of time I will be using all the other options. So right now I'll be using as query engine, and inside this I'll not give anything right now. Later on I'll also give some parameters over here. Okay, so I will go ahead and hit this. So this is my query engine now. Now, if you probably go ahead and execute this query engine also, you'll be able to see this is a query engine retriever. That basically means it is responsible for now retrieving any information that I give, right? Let's say I ask any question, it will retrieve the information from those indexes. Okay. So this is what we are specifically going to do. Now, instead, what I will do in order to execute our query, I'll use this object query engine.query. And let me just go ahead and write what is transformer. So this is one of the topic that is obviously present in this attention.pdf. Okay. So once I specifically execute this and print the response. Okay. So it'll take some time again based on from the indexings that is basically going to pick up. Once I get the response. So in 7 seconds, you probably got the response. And now let's see the response. So response basically says that over here, the transformer is a model architecture. So it is providing the response. Sir. In order to see it more properly, I will go ahead and write print response. Now see, most amazing thing. So here you can see the transformer is a model architecture that relies entirely on attention mechanism to draw global dependencies, input and output. It is used in sequence transaction such as language translation, replaces. Everything is there. Let's try something. What is YOLO? There are two PDFs. Now you can see I've developed a similar application with the help of LangChain, but I think this gets the seamless results. Okay. So now this query engine, say, since it is able to find the content from here itself, it is giving you the response. If it does not find, what will happen? I'll show you that also. So again, here you can see a new approach. YOLO is a new approach to that frames object detection as a regression problem. It uses a single neural network to predict bounding boxes. So it's working absolutely fine, right? So here you are able to get the response itself. Let me give you one more way how you can display this response in a much more better way. Okay. So what I will do over here, before print response, let me import one more library. So here I will write from llama_index, dot response dot response. It should be dot print utils. Okay. And I'm going to specifically import print See, there is an option. You can print metadata, you can print response, or you can print source node. So right now I'll be using print response. Okay. Now what this function does, see this, because here you will just not get one result. See, this is the topmost result that you're probably getting from the LLM, from the Llama index, from the indexing part, right? From that index it is querying, right? Multiple response also you get it, but which is the most suitable response, that will be in the first, you can basically say that it is the first item in the list. Okay. Now if I execute this, now you will be able to see the final response is this. Okay. Okay, final response. So here you can see print response. Here you are saying that, okay, I will also use one more parameter. I will say show source is equal to true. Okay. Now see, I've got two responses, and why this has been selected as the final response. So here you can see this is my final response. Along with this, I've also got two more, right? One with 81% similarity. So here you can see you look only once, real-time object detection, this, right? So here is the next one, right? Other information. So here from all these responses, this is the best response that is probably selected. So that is the reason it is showing you over here itself, right? If I probably go ahead and ask what is attention is all you need, right? So that basically means what I'm trying to say is that you will get multiple response, but which is the best response, that will get selected. And it also shows you the similarity score. So let's execute this. Okay. Based on this response, you can see if I use this pp print underscore response, and if I see the source node, it will provide you all this information from where it is specifically picking up all these details. Okay. So I will take this scrollable event. So let's go ahead and execute this, and let's scroll this. Okay. So here you can probably see this is my final response. The best response, the paper attention is all you need, proposes a new network architecture, along with the other source nodes, like whatever the other things that was given out of there, but it had only similarity of 81%. This had somewhere around 78%, right? So input, the law will never be perfect. Now see, the attention is all you need, proposes a network architecture called a transformer, this. But which is the best one? That will probably be shown. Now, the best thing about this is that I can still modify all these things. I can modify in a way like how I want. Instead of just two, right now I'm getting only two responses. What if I want 4 responses? What if I want 5 responses? What if I want 6 responses, right? Everything that is possible. So for doing that, how can we do that? Let me show you. So here I will say from Llamaindex, again by using Llamaindex only will do, dot retrievers import vector index retriever. Again, I'm telling you guys, if you don't have OpenAI API key, just put $5 credit, guys. See, so much things you can specifically learn, and this is all possible because I'm using OpenAI API key. Yes, I will show you open source LLM models also, but there also you're required to do a lot of setup. Okay, so that is the reason I'm saying that just put $5, just try to see it. Okay. Now, for this query engine, right now I've not given any parameter, right? So vector index retriever is there. So I've already imported it. Sorry, I'll not use this. Okay, let's use this because I think on the above I've used vector store index. Okay, perfect. So vector index retriever I'll use. Along with this, I will write from Llamaindex dot query engine, because now I'm going to change my query engine with a lot of parameters. I'm going to import retrieve query engine. Okay, and then I'm going to write from Llamaindex dot indices dot post processor, and let me just import the similarity processor, similarity post processor. I'll tell you why I'm specifically using these 3 libraries. So first of all, as I said, retriever. First of all, anything that I probably create as an index as a query engine, it becomes a retriever, right? I have to give that as a retriever. So this index that you probably see over here, right? This is a vector store. But once I probably execute this query engine, it is basically becoming a retriever, right? So, sorry, where it went? Yes, here, right? This becomes a retriever. So I'm going to create a variable called as retriever, and here I'm going to write it as vector store index retriever. I will provide the index over here. So index will be something like index, whatever index I've created. And here I will change my similarity top k. Let's say I want 4 different results. Okay. 4 different results. So this will be equal to, okay, 4 different results. Initially by default, it is giving you 2 responses or 3 responses, right? Here let's say I want 4. So I'll put this as 4. Now this retriever, right? I will give it somewhere, right? So here I will write query engine is equal to retriever query engine. And inside this, I will say, hey, this retriever is my first parameter. I will give the same parameter. I'm saying now, whatever my query engine is, this is the first time I'm giving this specific query. Before, the query engine was just, I'm saying index as query engine. So this was my retriever and I am considering that as a query engine. But this time I've created a different retriever and then I'm creating a query engine over here, right? So if I go ahead and write this query engine and provide you the retriever, then what I'm going to do, I'm going to execute this. Let's see. Now I will give the same question. What is the attention is all you need. And then finally you'll be able to see that I'm going to see the response. Now see, I've got 4 responses, right? This is my first response, right? Then you have source node 1, then you have source node 2, you have source node 3. If I probably see source node 4, source node 3, right? So all this information you're specifically getting. That basically means now out of this, we are able to get 4 different responses. So this is super important. And you can modify based on this, like how much, what is the kind of results that you specifically want. Now, I will show you this functionality also, which is called as similarity post processor. What exactly it does. Now guys, let's talk about this threshold that is given. See, there is a similarity of 81%. There is a similarity of 78. See, I can also make sure that I say that, hey, if the similarity is above 80, then only show me the response. Okay. And for that, we will specifically be using the similarity post processor. Okay. So let me go ahead and write post processor. And here I will write similarity post processor. Now inside the similarity post processor, I will give my similarity. There is a parameter which is called as similarity cutoff. And here I'm going to give you 80%. Okay. So I'm saying above 80, just give me above 80. And the next parameter, I will go ahead and add it over here. So I'll write comma and I will go ahead and write node underscore post processor, which will nothing be my post processor. Okay. Perfect. Now let me just go ahead and execute this and okay, tuple has no attribute call manager. So let's see what is the, okay, I have to give this in the form of list. That is the problem. Okay. So I can give multiple post processor like how I want. So this is executed. What is attention is all you need has got executed. Now you will be able to see the response. Only the similarity score when it is above 80, only that thing will get displayed. Okay. So here you will be able to see final response and here I'm getting 81. Only one response I'm able to get it. So this is really, really good. Okay. Now see, anything that is probably happening, whatever query you are specifically doing, it is basically happening with the index. Right now, entire index is stored in our memory, right? And there may also be scenarios that I really want to store this entire index inside my hard disk, right? As a persistent storage. So let's go ahead and see how we can basically do that. Okay. And for that, I will just write this code. Let's see this code. This will be fun. And let's observe this code. Okay. So first of all the imports are basically happening. We are using this vector store index, simple directory reader, storage context. And this we are using load underscore index from storage. Okay. See, here we are creating a persistent directory. That basically means I'm going to create a storage folder over here. So here I will somewhere create a storage folder. And all this index, whatever parameters, whatever weights it has, it is going to store inside this particular folder. And whenever I really want to load those index again, instead of just querying the index that is in the memory, I will first of all load from my hard disk and then query, right? So that my application will keep on running. So I will try to store everything inside this storage folder. So that is the reason we have written, if not os.path exists persistent directory, then we have written simple directory. We are loading the entire data. We are creating the index. Okay. If the index is already created, then what will happen? Once the index is created, we will store this. So over here we have written index.storagecontext.persist. So whatever parameters is basically present inside this index, it will get stored inside this particular folder, right? You will be seeing multiple parameters will be there. What all files will get created. Okay. Else we will go ahead and again load it from the default from those particular folders. So that is the reason we have used this storage context, and we are going to load this entire storage context in the form of load index from storage. Okay. And then finally I'll get my index. Okay. Then again we do index as query engine, and what are transformers, I'll get the response. Again, understand what is the simple mechanism over here. Okay. What we are doing over here is that, let's say I will write it over here. Okay. So this is my index. Okay. Index basically means what? In short, this is basically having the vector embedding, right? Vector embeddings. Now vector embeddings has different files, right? Different parameters, how the vectors look like. So in short, this will having around 4 to 5 files. So 4 to 5 files. Right now, all these files information are present in memory. We cannot keep in memory, because if my PDF keeps on increasing, then my memory will keep on getting exhausted. So what I will do, I will take this index and store it in my disk, right? My system disk. And whenever I require this index, I will load it from here and then I will query it. So that is what I am actually doing from this specific code, right? So I'm saying that if this directory does not exist, then I will create this index and then I will store this index in that particular directory. Else I will load from that particular directory, right? So now let's go ahead and execute this. If I probably go ahead and see the response, you will be able to see that I'll be able to get the entire response. And once we get the entire response, you will also be able to see that here is all the files that is created inside this folder. See, I got the response over here. Now let's watch each and every, see, default vector store. This is my default embeddings vectors, right? You can see over here. Graph store, right now, nothing is stored with respect to DAF. Doc store, this has metadata information, right? With some hash key and all. Index store, so it has some information with respect to this, right? In short, these are mappings, one with other mapping. But default vector store, this is the main embedding vectors that is created out of it, right? So I hope you were able to understand this video, right? And this is how you create a basic RAG system with the help of Llamaindex and Openai. So yes, this was it from my side. I hope you like this particular video. I'll see you all in the next video. Have a great day. Thank you and all. Take care. Bye.